Welcome to the next part of the tutorial, and in this tutorial we will read the Excel spreadsheet that we prepared in the previous part into IBM SPSS 19, and then we will check some assumptions before doing some statistical calculations to answer our research question. Okay, so the first thing you need to do is open IBM SPSS 19, go to the Start menu and type the name of that program into the search bar, select it from the list, and wait for it to load. So you see the splash screen first, and then you can dismiss this first window which is asking you if you would like to open a previously used data file. So say cancel, then go to File, Read Text Data, and change the field that says Files of Type from Text to Excel, and then find wherever you saved the Excel spreadsheet. So for me it's already here, but you may need to navigate to the location where you saved it. Click on the Excel spreadsheet you want to read into SPSS and then click Open. And this will now read the spreadsheet into SPSS, but it will first ask you if you would like to use the first row in that file as variable names. And you do want to do this, so leave this option selected and say OK. Right. So SPSS is slightly confusing. So we have two different screens, and later on we will have a third window. So at the moment we are in variable view, which you can see at the highlighted tab at the bottom of the screen. And variable view gives you an overview of the columns that you have in your data file. So we have a column that represents a postural sway measurement without any tape or brace, and then we have a separate column for 5 different taping and bracing techniques. And in the previous tutorial part, we calculate the difference between these by subtracting the postural sway with a particular taping or strapping technique from the postural sway measured without any taping or bracing technique. And what we would now like to do is we would like to know if the postural sway was significantly different with a particular taping technique compared to the postural sway measured without any taping or bracing. So what we want to do is basically run 5 separate comparisons. So comparing no taping or bracing to heel lock, comparing the same thing again to figure of 8, same thing to basket weave, same thing to A60, same thing to air sports brace. So 5 separate tests, and because we are comparing 2 sets of data, you would usually use a t-test to do this. And additionally, because we took the measurements from the same people, so the same person provided postural sway measurement without tape or brace and with a particular tape or brace, this makes it a paired t-test. So paired t-test because we have pairs of observation for each person. So as I said, the common statistical test to do this is a paired t-test, and this paired t-test makes some assumptions. And before you can actually run it, you should check whether the assumptions of this t-test are met. So the assumptions are that your data should be scale data. So scale data means that the measurement must have units that have a known relationship to each other. So the units in which postural sway is measured is millimeters, and how it is measured is you stand a person on a force plate on one leg, and then you measure how much they wobble from the center of force, so the place where most of the weight is applied in any direction. Okay, so millimeters is unit of measurement where the relationship between any 2 points of measurements are known, so that's okay. And then the next question to make it scale data is the 0 meaningful on this scale? So for us, if you have a measurement of 0 postural sway, that would mean that the person was entirely stable and didn't wobble at all. So this is a meaningful 0 because it means no postural sway, total absence of postural sway. And that means that the assumption of having scale data is met for this test. The next assumption the t-test makes is that your data is approximately normally distributed. So it means if we plotted all the postural sway data we have, it would look roughly like a bell-shaped distribution, and this bell-shaped distribution is also called a normal distribution or a Gaussian distribution. And this is the first thing that we need to check. So the relevant measure of interest is the difference score between postural sway without tape or brace and postural sway with a particular taping or strapping technique. So we're going to check whether the difference scores for each of the 5 techniques is approximately normally distributed. To run this test, you go to Analyze, Descriptive Statistics, and then Explore. You then move the relevant measurements over to the dependent list. So click on the first difference measurement, hold the Shift key on your keyboard, and click on the last measurement of interest, still holding the Shift key depressed. And that will highlight everything in between, and then use the arrow to move it over to the dependent list. Then go to Plots, deselect Stem and Leaf, which is additional output that you do not require, and then check the box that says Normality Plots with Tests. So these tests will tell us whether the different scores are approximately normally distributed. Then press Continue and OK, and SPSS now opens a separate window, which is an output window, and this output window has two separate areas. So one is the navigation pane on the left hand side, and that allows you to quickly access specific parts of the output, and then the actual output is on the right hand side, or the right hand pane. So the first thing we need to check is, did we use the right data? So go to the case processing summary, left click on it in the navigation pane, and then it highlights with the red arrow the table that corresponds to that case processing summary. And we just quickly check that we have 5 difference measurements entered here, which is correct, and therefore these 5 different techniques that we used. And we check that the number of observations corresponds to the number of participants that we used, and that was 27, so that's all fine. So then, to actually know whether the difference in postural sway without any taping and bracing technique and with a particular taping and bracing technique is approximately normally distributed, we go to the tests of normality, and it offers you 2 separate options. It offers you a Kolmogorov-Smirnov test and a Shapiro-Wilk test. For small samples, so for a small number of participants, the Shapiro-Wilk W test is more appropriate. So small here is defined as less than 200 observations or participants. And then you interpret this test exactly the same way as you would interpret any other statistical test. So you look at the significance column and you check whether the result is smaller than 0.05. So that tells you if the result has a 5% probability or less to be arrived at by chance. So here all of the probability values are smaller than 0.05, and what this tells us is that the difference in postural sway is significantly different from a normal distribution. And at this point, we basically can no longer run a paired t-test to compare the measurement with and without a particular taping and bracing technique, because the assumption of normal distribution is not met by any of the relevant data. And in the next part of the tutorial, I will show you what test you can use instead.